Dear students, in this video I am going to explain you about representation of algorithm. This topic I am going to upload for study material of computer science in this week. A software developer or programmer uses algorithm thinking to analyze problem and identify the logical steps to reach the proper solution of a problem. Logical steps means how you solve your problem, and a logical steps depends on person to person. Maybe your logic is different from another person. It depends on your thinking, how you crack the problem. Simply like if you are solving a problem of Sudoku, and maybe your technique is different, and how you solve it, how your means how you process your brain, and same way another person can think in different way to solve a problem. Once the steps are identified, the steps are logical steps. The need is to write down these steps with the required input and desired output. There are two common methods of representing an algorithm: flowchart and pseudocode. Logic of a program and flow of a control during execution of a program are ideas to represent algorithm. Flowchart. Flowchart is called as visual representation of algorithm, means graphical representation of algorithm. Whenever you write algorithm in English like statements or in natural language, but sometimes it may be means difficult to read out or difficult to understand, but the flowchart is clear cut because it is a graphical representation. A flowchart is a visual representation of an algorithm. A flowchart is a diagram made up of boxes and different types of shapes and arrows. Each shape represents a step of solution process, and the arrow represents the flow of the order or data from one step to another step. And this is the table which contains different flowchart symbols. First is this symbol, rounded corner rectangle, and its purpose is start and stop. Whenever you start the flowchart, that time you use, and when your flowchart ends, that time you use this step. Means you have to write the start to start the flowchart, and at the end of the flowchart you write and inside this symbol. It allow means it allow to start the flowchart or to end the flowchart. That's why it is called as terminator symbol. And this is a rectangle. It is used to represent process, also called action symbol. It represents a process, action, or single step. This is called as decision step. It is called as a diamond, and this is a decision or a branching unit, and its purpose is to write condition, and the result of this step is either yes or no, or you can say true or false. And this is a another means symbol here. Its purpose is to show input and output, also called as data symbol, and it is called this symbol is also called as parallelogram. And its purpose is to show input and output, like whenever you simply input data to the computer, and when you get the finalized output, and in this way you can use the parallelogram to show the input and output in the flowchart. And The last one is arrow here, and arrow is called as connector. It connects one step to another step. One more step should be here. But it is a circle, and the purpose of the circle is when you are making flowchart in a copy, and when your page finishes, at the end of the page you have to write means on circle like page number 1. In this way, from the second page you can start that flowchart again. Next, there is one example. Write an algorithm to find the square of a number. Before developing the algorithm, let us first identify the input, process and output. Here, only one number is used to find the square of a number. So, input is a number. Second is a process. Process means you have to multiply the number 2 times. And output is a square of a number. So, there is only one input and one output. And process means to multiply input again with the input. Now you see here, this is the flow chart here, and the first step is to start the flow chart. Next is parallelogram, and its purpose is to input number. Next, this is a rectangle. In rectangle you have to type the process means calculation. Then in this step, what we have shown here, we have shown the output of the algorithm. At the end of the algorithm or in flowchart, we use here stop. Now you see this one. This is another flowchart. Okay, you don't be confused. Means when you are not understanding about the flowchart. But in coming video, I will explain you about the flowchart, or I will make different type of flowchart based on the algorithm. So you see this flowchart. In this flowchart, means there is a use of condition here. Its purpose is to show the problem non-functioning light bulb. Whenever you have to check the bulb is functioning or not. How you check it? First, this is the start. Then the bulb is switched on or not. Means the purpose of the diamond here is to write the condition. If it is no, switch on. If it is yes, means bulb is on. Maybe it has another problem. Now you see here, if it is switched on, now again another condition applies here. Is it burned out? No, call the electrician. See here, when the output of the first condition is no here, then you switch on, and if bulb is on, then you see here automatically the connector here arrow is going to the stop. If it is burnt out, means there is a need of calling electrician, then after that again this arrow is going to the stop step. If the bulb is burnt out, if it is yes, then you replace the bulb, and then after that at the end is stop here. In this way the problem is solved. These are also called as logical steps. Means flowchart is representing logical steps in means pictorial way. Now pseudocode. Actually the P is silent here. That's how we say pseudocode. Pseudocode is same like algorithm, but its steps are clear cut. Means its steps are related means with the programming language, because these days we usually use high level programming language, and a high level programming language contain English like statements, means we can easily understand them. So this pseudocode, its steps are clearly defined, and these steps are related with the programming language, but not a programming language words here. We are not following programming language syntaxes here. Just we are using some steps. But in algorithm, what happens that means each person write algorithm in different languages. So sometimes it is a little bit difficult to understand. Maybe the steps of algorithm are lengthy, and somebody who has knowledge about algorithm, so such type of person write steps in short and clearly understandable way. So, but in pseudocode, all steps are clearly defined. So you see here, a pseudocode is another way, and we also say pseudocode is another way of representing an algorithm. It is considered as a non-formal language which helps programmers to write algorithm. It is a detailed description of instructions that a computer must follow in a particular order. Means whatever we write in pseudocode, after pseudocode, we have to write the program. Means what we will do for a program using a programming language. Just we are translating pseudocode into the programming language. So it is a detailed description of instruction that a computer must follow in a particular order. Whatever we write in pseudocode, we just as it is we will translate in the form of programming language. So what are the steps of the pseudocode? These steps are must be followed by the computer. No specific standard for writing pseudocode exists. Okay, means here these are means just we have defined the pseudocode. Maybe you can use means another types of steps, or because here mathematical operators are not here, and means whenever we use mathematical operators, that time it is little bit different. And the word pseudo means not real. Pseudo code means not real code. Actually it is not a real code, it is not a program code, it is just for understandable purpose. Following are some of the frequently used keywords while writing pseudocode. First is input, compute, print, increment, decrement, if else, while, true, false. Here, one example, write an algorithm to display sum of two numbers entered by user using both pseudocode and flowchart. Pseudocode for the sum of two numbers. First is input num. Input means we have to input the number. Next, input num2, compute result equal to num1 plus num2. At the end, print result. This is the flowchart. The first step is start. In this parallelogram, what we have written here, to input num1 and num2. You see here what is written here, read, but in place of read you can write input symbol. Means whatever the step, it should be clearly understandable. Actually what happens whenever you are writing the pseudocode, you are writing pseudocode for your means to whom you have to show the pseudocode, and the pseudocode should be understandable to you and to whom the pseudocode you are showing. This next step is result num1 plus num2, then print result, then stop. And next is here, write an algorithm to calculate area and perimeter of a rectangle. See here, what is the pseudocode here? First input length, input breadth, then compute area equal to length into breadth. You see here the pseudocode steps are written in capital letters. Actually it is not defined, but it should be means why it should be used to distinguish between the pseudocode symbol and the variable symbol here. Means what we are inputting to the means algorithm here. This is the input for the algorithm. Then input breadth, then here compute area equal to length into breadth, then print area, then compute, then the print perimeter. Same way, just it is translated in the form of flowchart. First is start, then next input length and breadth, then rectangle is for calculation, length into breadth, then this here parallelogram to show the area, then again rectangle is to calculate perimeter, then this parallelogram to show the perimeter then end. Okay, thank you for this video, ma'am.